justice, I suppose, as the white man says, because we haven't, we're only going to be discussing this, discussing preprocessing of textual content or something today and probably part of tomorrow. What I'm going to suggest you do is, I'm going to again address the checkpoints. If you've done that, that's fine, but if you haven't and you've been struggling, we're going to try and see if we can buy ourselves some time here. So I'm going to adjust the checkpoints again, hopefully that will help. But as I'm setting up, I wanted to find out if, also, today at 18 hours, we have a quiz. Michael Kelly, lecture theater. I never got a response. I proposed 7 hours. For those of you that I think stay in Matero or something like that, there was a complaint that apparently it's dangerous. And I sympathize with you, but wait a minute, no, I have. But, I never got any feedback, so the quiz is at that time, sorry. Okay? But other than that, are there any questions so far about, I'm sure you've had a chance to kind of like think about or to read up on what we've been doing, reading up on what a sparse matrix is, I guess the importance of doing that as opposed to using PD or get done with, you get accomplishing the same thing. The only difference is that PD or get done, I guess, gives you what? Boolean values, is it true, false, or something, but you know that in Python, it's true or false thing here. It's true is 1, false is 0. We told us in Python. So just to hoping that it's done. Just to hoping that that's done. Are there any questions? Are there still quickly?
Yes, regarding the answer criteria of assessments.
Yes.
Are we required to use, for example, if you're not given as a variable, right?
Yes.
In the sense where you use displacement. So anything aside from that, any variable name is fine. Maybe we need.
I mean, if you want to use your variable name at the very beginning, right? You just tell us, I don't know if you want to use here. Here is equal to that's a variable. Then you say, because if it is x is equal to that variable, then you start using that variable. That's fine. But if the issue is with variable or something, you change that. That's not a problem.
My question is
because it's a long thing.
No, the function from the previous assessment, the function name, I saw that you started with fxn.
Yes.
But is that necessary for something that you want?
No, I think I mentioned early on in the process that that's my naming convention. This is how I normally write code, right? That's my naming convention. You don't necessarily have to do that. And I do that because I wouldn't want my variables to conflict with, with any other libraries I may be using or something. That's just, for me, that's my internal naming convention. You can use whatever variable names you wish. I don't know why this thing is fading here. Are there any other questions or thoughts about it? I had hoped that I could actually use. It looks like I'm going to have to. I'm going to have to use Google Slides or something. I don't know what's happening here with my connection or something. Are there any other questions or thoughts or something? Is there? I know. Sorry, there's a group which reached out to me. Hi, we are wanting to see you or something, and all that. Please, I've been held up. It's been a busy period. In fact, there's a conference going on right now. I just had to sneak out here, but I'm happy to meet with you right after class virtually if you want, because I won't have time to meet with you in person. If it's a very quick, if you want us to just meet quickly or something, I'm also happy to, I mean, I'm happy to see you today after the quiz. You know yourselves, there's a group that reached out to me. I can't remember the group number or something. Apparently, they need clarification on what they're doing. Otherwise, Monday next week, I guess, I'll be in the office and stuff. So if there are no questions, we're going to continue. You know, our discussion of this lecture series. I don't know. Any thoughts about using the technique number 2 on how we go about transforming nominal attributes? Did we observe anything peculiar, anything interesting you'd want to share with the rest of the class? Yeah, you know, somebody was like, no, send us homework. No, I told you it was homework. But I don't know if people had a chance to look at this, and if you have any thoughts. What's some of the, oh, yes. Yes.
Is it enough for a test and one of the techniques, or should just know how to write down?
Is it enough?
Is it enough for a test? Just know one of the techniques. If I ask a question,
Is it enough in the test? Now, you know, we had a very interesting conversation at the event I was at, right? You know, I learned quite a bit here, especially like in the broader field of security as it relates to AI. Professor Zimba from Zikas, you want to look him up, right? If you're interested in security, and maybe you're interested in pursuing what you're doing here further, you want to look up what he's doing here. I learned quite a bit here. And one of the things we're talking about was the problem, the challenge that is there when we are teaching people like you, right? These concepts is, it's almost always like the incentive is just to pass, right? It's marks. You know, like if you ask me, right, what I would want, an ideal case for me would be for you to understand everything. But in the test, if you're told to one hot in code, nobody cares if you decide to use the one hot. His question is, would it matter if we ask a question, and we shall ask in the test or the exam, by the way, if we ask, we shall ask write code to one hot in code or something. But if we ask you, right, can you one hot in code this attribute, right, in the data set given? We don't care if you use get dummies. I don't know if I'm answering your question, or if you decide to use scikit-learn to do this. It doesn't matter. I mean, you're accomplishing the same goal here. However, sorry for this here. You know, in the exam, if you start writing Java code here, no. And also, when I specify, use Python code. You know, I discovered, right, apparently there's Spring AI or some stuff like, I didn't know. Dr. Nyirenda is the one who was telling me, because at the very beginning I was joking about tools, right, and programming languages. I was like, good luck if you're planning to use Java, right, for machine learning or AI. And Dr. Nyirenda was just reminding me. I looked it up also. There's a new, I don't know if that's a library or something, Spring AI or something like that. I thought that was strange here. But yeah, so it doesn't matter. Is that fine? But my question, are there any thoughts? If there are no thoughts about this, you know, how we go about using the ordinal encoder, remember that this is an alternative. This is technique number 2. Technique number 1 is a simple technique where you just use your dictionary to replace. And you can replace by using the pd.replace, right, function if you wish. You can use the pd.replace function. It appears I don't have it, but you can use the pd.replace function. And you know, the pd.replace function you can look up what this is all about here by just looking it up, is it? I think I still have pd here, so it's like pd.replace, right? If you do a help, if you use the help built-in function, this thing is going to pd. No, but it's supposed to be there though. Sorry?
Maybe it needs bracket.
No. It's supposed to be. It's supposed to be there. You mean this? It turns out that I think what he's saying is that attributes as method is supposed to be saying this, but it still doesn't exist here. It's actually supposed to be this. It's a why is this happening? Hey. The live demo has failed. No, it's a function that is probably applied on a series, right? PD is what? PD.replace. So it has got to be a series. So if we do this, I imagine, by the way, you can do a dot, right? For accessing the attributes. If you remember, we didn't discuss this. The way that I've been showing you how to access these variables is, yes, exactly. But it turns out you can use a dot operator. But the dot operator assumes that the way you are naming your columns is in such a way that there are no spaces and all those things. You understand what I mean? That's why I was saying that one of the things that you do as part of that process where you're preprocessing, I guess, data preparation is you have got to rename the columns, for instance, if you want, right? So what I was saying here is if I decide to get gender, for instance, right? Gender will have the replace, I guess, so I can do this, right? Right? This is why it was failing here, because we are trying to access it in a different object or something like that. But anyway, so you can use a replace method, right? And really, by just looking at this here, you have a sense of, what sort of parameters you have got to feed this thing, right? Read. But also, you know that you can create your own method, a method that takes in a dictionary, right, as input, and then you just replace it, your values. Simple. You do the dot apply. So in fact, I would argue that I'll posit that there's probably three options that I can think of right now. Now, the other thing here is something that we're going to see very, very soon. Sorry to disappoint you, those of you who are commenting. It would be nice if there could be another guest lecture. Dr. Nyirenda and Professor Pira are not coming here. I told them I volunteered, I would do this, and they said, okay, it's fine. So you're stuck with me until the exam. Sorry. But so this is going to pop up when you start looking at unsupervised machine learning. It turns out that when you're clustering, and we're going to use, if you remember, I said we're going to use k-means clustering. When you're clustering, it turns out that the patterns that you derive, right, from your model that leverages clustering and supervised machine learning is best visualized if you scale your data. So typically what you do is you would, using the range of values that you have, you typically scale those values so that they fit into the values 0 through to 1, right? So if you think about it really, again, you can easily scale them by maybe dividing. If it's max, if our marks are from 0 to 100, how do we ensure that they're scaled down to 0 to 1? What would we do? What? Oh. We have max. Okay. We have max. 0, 15%, 20%, 89%, 100%, 99%. Our range of values for the field final exam score is 0 to 100. These are percentages. How do we scale them down so that they fit into the range 0 to 1? Yes. Sorry? Yes, divide by 100. That's it. So what I'm trying to tell you is that you can scale actually by just performing a mathematical computation. In fact, I remember Professor Kaleji from CB was doing a deep learning session, and we're using an image data set, one that has digits if you've played around with Keras. And one of the code snippets had a part where you're scaling pixel values, right? You want to scale grayscale versions of pixel values that use a bit depth of 8, right? A bit depth of 8. So meaning that the way these things are is if they're using a bit depth of 8 is this, is it? Something like this. The range of values you're going to have is, you're going to have a total of 256 if you're working with images, right? But we know that the pixel values for grayscale have got to range beginning in 0, right? 0 is what? Is it black or white or something? What is it? This is elementary computer science, first year computer science, if you remember, right? So what he did was, like the largest value, and I showed you this when I was visualizing a 28 by, what was that? Was that a 5 by 5 image where you had numbers, right? And I told you that those numbers are tied to the pixel representation. If it's RGB, it's going to be different, but if it's grayscale, using a bit depth of 8, which is usually standard, in fact, if it's grayscale using a bit depth of 8 means you're going to have a range of values, right? Different shades of gray from 0 to 255. So if you're trying to scale those values so that they fit within a 0 to 1 range, all you're doing is you're just dividing by 255. That's what I wanted to say, right? You're scaling. So it's really simple. It's not that difficult to scale. It's not that difficult to scale, right? But you can also leverage min-max scaler, right? So you just go to sklen.preprocessing and then you import min-max scaler, right? You identify the fields that you want to scale, and you notice the pattern is the same. You either fit and then you transform, right? So that this thing learns, right, how the scaling is supposed to be done. Or you can do it in one step, which is what I've been doing, fit underscore transform. So these two methods here. And then afterwards you have access to your data. It will be scaled on your behalf or something, right? So pretty straightforward stuff here. Now, it brings us to a discussion or continuation of our text preprocessing, right? It's like we have our corpus, right? The nice sort of thing about what we're doing here is we have our corpus. Our corpus is, what problem are we working on? What's your project? Which data are you working on? Sorry?
Transportation.
No. I mean the problem in your group. What group are you in? The group-based project. Parliament, right? Which parliament documents? Okay, so parliament, let's say it's the acts of parliament or something. One of the things you're going to have to decide is, for the acts of parliament, it's like, I don't know what sort of thing you're doing here, but it's like, how are you defining the document? Right? That's a question you're going to answer. Assuming, and one of the examples I was giving at the event I was attending last week is assuming you are viewing the actual acts as being documents. The actual acts of parliament as being the documents. What you're essentially saying is that, and I think I have this document actually. I don't know. I think I have this document somewhere. What you're parliament. What you're essentially saying is that, this parliament. I thought it was here somewhere, right? What you're essentially saying is that you could decide to say, well, we are going to, sometimes what we're going to do is for each, it took a while to download these documents. Some of them are scanned, by the way. And what I was doing is I was converting them to text also. But what you would be doing is, I don't know if you can see this, but you'll be saying each act is a document, right? So your corpus is going to comprise of all of the acts. So in other words, this thing, which is in my gzip file here, this stuff out here, these things you are seeing here comprise my corpus. Each individual file is my document. I'm not saying this is your use case, I'm just giving you an example. Right? Now, each individual is a document. And for all your problems, the tokens that you are working with are words. You understand? So in other words, if you remember our definition of what a corpus is, what a document is, and what a token is, what we are saying is that you're going to have to do something smart, like I've done part of the process, where you get the PDF documents, all of them, you convert all of them to text, right? Because you can't insert them into a pandas data frame. You convert them into text, and then you start reading the text, your content, right? Document text file by text file. And in effect, each text file is going to result into like an individual observation or something. And then after you do that, you start doing the fancy things that we introduced, is it? You clean up, right? You remove your stop words. In fact, you case forward. You remove your stop words. You stem if it's applicable, right? Or you lematize or something. You remove punctuations. And then at some point, you're going to have to tokenize, right? Now, we've got into a stage where we have tokenized. Is it? So the question is, and we know how to tokenize. We had a discussion about how you tokenize here. You do this when you're tokenizing this document here. You know, this document has a lot of, but why this thing? This is the first document. The way you tokenize this, and by the way, you'll have to do other smart things here. Obviously, I don't know if you're going to use a regular expression package, but you have got to, because this thing is, the unfortunate thing about this is that it's, observe, it's multi-line, right? So for you to process this, maybe one of the very first things you're going to have to do is string it together, right? If that makes sense. And you can use regular expressions. I told you this. What I can do here is I can say, I'm going to use regular expression, and for each new line, Mr. Kate, please replace this with a space like this. I'll say the mode is regular expression or something like that. So what I mean is, in fact, for most of you, what you're going to have to do is this. So that this text, the chunk of text that you're working with, is like a single straight line. And you won't see that this is a single straight line because it's wrapping to the next line here like this, right? It will be a lot easier for you to process. And then from here, you say case forward, remove stop words, remove punctuations, tokenize, right? Well, or remove punctuations and stuff, and then you limitize and stuff, right? But after you limitize, right, we are saying that the next step is for us to do anything meaningful with this, we have got to convert this into a numeric representation. And the question to ask is, how do we represent this into numbers, right? That's what we want to answer today, I guess, or something like that. And what we're saying is that there are a number of techniques, like for instance, one of the simplest thing, which again I introduced you to during our discussion of lecture series number 3, is the bag of words model. So in essence, the so-called bag of words model, right, is really a simple and widely used approach for representing textual content in a numeric format. And what it does, the way it operates, is it treats text such as sentences or documents as a bag of words, right? In fact, it's a frequency of words, like how often a particular word occurs in that document, right? So you're keeping track of the word frequency. And if you're sitting there and you're wondering, but how is this done? I went out of my way. If you went through the, and if you've read or you went through the notebook, you notice that I mentioned that we can use scikit-learn, sklearn to do this. But for you to understand what is going on, it's important to understand the heuristic, right? How this is accomplished. So the way it works is you start off by, first of all, creating a vocabulary, right? So a unique set of words from your entire corpus, right? I think I have a, yeah. So you create a vocabulary of words from your entire corpus. It's like you're going to come here, using all of these things here. You say, what is the unique set of words? If I was to say, introduce yourself for something, I'm Lighton, you know, I'm Chela or something like that. What we're saying is we're going to look at all of your responses and determine the unique set of words. I is going to be common for most of us, right? But maybe our first names are going to be different here. So it's like we are compressing, we're just trying to identify the unique set of words, right? That's the first stage of this heuristic, which is pretty straightforward, right? And then afterwards, we're saying for each document, right, we want to count the occurrence of each word in the vocabulary. So I don't know, I'm sure this is making sense, but you have your unique words, and then you're saying for each document, you're going to be checking, does this word in my vocabulary occur in my document? If it does, +1. Or rather you count. In fact, the heuristic is such that if it does, how many times does it occur? I think I have an example, but I would like to use something very, very simple here. Imagine we are saying we have I am Lighton, I'm Chela or something, I'm Dennis, I am in 4th year or something like that, right? I'm alive or something like that. I'm the class rep or something like that. So what we're saying is that we're gonna say what are the unique words in here? And the unique words, if you're paying attention here, to be one of them will be I, am, right? And typically they are arranged in a certain way here, right? We don't have, and then we can skip the names here because the names are going to be so many, right? In fact, you've case forwarded these things. I am, okay, we can include this, right? Alive, class, right? Rep, and stuff. And then you start counting, right? It's like, how many, this is what we're calling our vocabulary. This would be our vocabulary here, a unique set of words, right? And then for each document, you start checking. If we look at the word I, how many times is it in here? You say it's 2 here, right? I. M, how many times is it in here? M, so it's 2, right? Chela, how many times is Chela in this document? 0. No, in my document it's 0, because we are looking at this document by document. So you're going to come in here. We're looking at document number 1, right? You're checking. Does Chela appear in here? No, it doesn't, so it's a 0. Alive, does it appear in here? Yes, 1 time. Class, there's no class in this document. The word class doesn't appear, so it's 0. Rep, 0. And then when we come to, let's say, the document with Chela, I appears 2 times, right? M appears 2 times as well. Chela appears 1 time. Alive doesn't appear. Class appears 1 time. Rep appears 1 time. So if you think about it, you can easily implement this, right? You start off by saying, I'm going to compress all of the textual content in my corpus, stitch them together. In fact, the simplest way of doing this is get the first document, convert it into a list, merge it to the next list, right? So you're converting them into lists, and then you are merging them, and then afterwards just cast it into a set, because a set contains unique words. That's my simplest heuristic, right? Once you do that, you've constructed your vocabulary, right? After you construct your vocabulary, you then start looping. So you're going to, it's like you're going to loop 2 times, is it? For all words in the corpus. For this, right? And then in the next for loop, for all documents, right? For this, and then in the second loop, for each word in the document. Check, right? In fact, you have 3 loops, is it? I think. If you look at the implementation of this, I don't want us to just get to count vectorize. There's a simple way, right? Use API here, scikit-learn, right? Count vectorizer. That's it, done. But we're saying we're trying to understand this so that you figure out how it works. And in fact, it'll be a lot easier for you to understand TF-IDF if you understand this, right? Because there's motivations for why you'd want to use TF-IDF as opposed to this. Like, for instance, the things that appear often are irrelevant, right? All of us in here, if we ask ourselves to introduce ourselves, right? All of us are going to have the word I and M or something, assuming we don't consider that as a stop word. You notice that the frequency is going to be the same, right? So the common occurring words are meaningless, in other words, for most use cases. And because they are meaningless, this thing becomes useless. If you implement, right? If you implement a model using this sort of approach, it's going to think that these things are important. I know these are stop words, but imagine, I don't know what here. Fourth, for instance, right? All of you would probably, if I say, tell us what year you are in, most of you are going to say 4th year. So 4th year is not that important, right? Yeah? So anyway, so you are looping this in such a way that you construct your vocabulary, and maybe let's just go through the heuristic anyway. You're constructing your vocabulary, and then afterwards what you're saying is that for each document, in the case of Parliament, I counted them. I think it's close to like 493 or something. So I'm going to say, and if you've loaded these into pandas here, because it's iterable, a series is iterable, you just say for document in the series, and then you're processing. But as you're processing each document, you say For each word in that document, you're again going to check, right? Not for each word, for each word in the vocabulary. How many times does it appear in my document? It's like you're counting. Does this make sense? Right? So, I mean, I've simplified this slightly here, where we're saying, you first of all, step one, you get your corpus. Of course, we are assuming at this point you've performed all those pre-processing operations. You create your vocabulary. Your vocabulary comprises of unique words. Now, here's the thing. I don't know how many of us have read up in advance here, but because we work with English, it's like, how many words do we have in the English language? Roughly. Sorry? It's many, right? You want to look it up. I mean, you can look it up, I guess.
Sir, I have a question.
Oh, yes.
I just need a little bit of clarification.
Could you let them know that I'm making noise? We have an important class here. We're in 4th year here, right? We have a very important class. Do you want to? Excuse me? Hey, Miss Madam, could you tell them that they're making noise, please? Do you mind? Please go away if you want to make noise. We are busy in there. We're in 4th year. Thank you. All right, so somebody has a question. I think Mr. Chelasa. Yes?
Right. So, just a little bit of clarification. I just want to find out, who is going to use this information that we are transforming in Preprocessing? I mean, what is the whole purpose of, okay, getting the data, right? Let's just say the Act of Parliament and all the other stuff and everything. But then, now the question comes,
Who is going to use?
yes, like what are we doing? Are we training a new AI?
So you are going to use it because you're doing this for marks, right?
No, I mean,
But I'm just joking. That's an interesting question, right? And here's the thing. And I'm hoping maybe by the time we're getting to the 12th of September, you understand this. I was showcasing examples. Okay, I'm going to start with this, right? Paul, one of the participants from the workshop. And by the way, if this thing works out, maybe I'll work with some of you who usually when you're done, you'll be interns or something. Paul from Parliament, right? When I was giving an example, most of them were confused actually, right? They couldn't piece the different pieces of the puzzle together. And I know this because I've been teaching this for quite some time. I interact with people, in industry and stuff, so I know. And so after I gave some examples, it comes to me and it tells me we have a problem, right? Those parliamentary proceedings, what happens is people will send questions in advance before they are discussed in Parliament. But the challenge they have is, in most instances, they will have duplicate questions being submitted. So I would be interested in maybe some important aspect in higher education. I may not be the only one, right? So there could be like multiple people that are submitting the same things. And so he's saying the challenge they have is that they typically have duplicate questions. It's a huge challenge, right? You're wasting people's time there. So what they want, what you're saying is, one of the very first things they would want us to do together is, can we build a model, right? That tells us if they're duplicates. Now, you can't, okay, I know what you're saying. Well, we can use semantic search. Yes, that's probably the simplest way of doing this, right? You kind of like use ChromeDB or something, a vector-based database and stuff. But one of the things you can do is you can build a classifier, right? Submitted or not submitted. It's a binary classifier, right? And then you're checking to say, if you have a document that has this text, can we classify whether it has been submitted or not? You understand? Another easiest thing to do is, if you're like me and you're overwhelmed when it comes to WhatsApp, right? Some of these things I don't even read, right? I use this thing. I'm going to showcase this group with all UNZA lecturers or something. 395 people. The things that people post there, some of them I'm not interested in, right? Memes, duplicate news. What I can do is I can say, I'm going to build a classifier that tells me, right, based on my preferences, is this post on WhatsApp relevant or not to me? And in case you are thinking, well, but how do you implement this? Well, I mean, you've been taught software engineering here, but the simplest way is there's a way of exporting your chart, right? You can export your chart and read it after. There's some groups, I don't even check messages, it's just too much for me, right? I think it's audit, but I can't keep up. So easiest of doing this is I can build a solution, right? That tells me what is relevant based on me. So what I would do, right, to build that sort of solution is I would say, I'll obviously label, I'll create a training set where I label things. If you see something that has this sort of text, it's relevant. Like I'm mostly interested in research, collaboration, papers, and all those things, right? So if you see something that has this text, relevant, if not, not relevant. Now, for you to get to that stage, for you to build that sort of model, right? For you to train a model, to learn a model that does that, you have got to go through the series of steps that we're describing. You understand? Does that make sense? But there are a number of, in fact, if you look at NLP, right, and text, this is probably low-hanging fruit, actually, if you think about it. UNZA alone, I don't know if I use this as an example. UNZA alone, if you pay particular attention to the UNZA Facebook page, right, it's always the same comment. You don't respond to emails. You don't answer your phone calls. And you know why they're not changing? Nobody in public relations, they're the ones that are responsible for that, has the time to go to an UNZA post and read all the comments. So how do you solve that problem? And some of these things are being inbuilt in Facebook, right? You can build a topic, you can leverage topic modeling, right? Where you classify these things based on topics, different topics. This topic is to do with registration or enrollment or something like that. Or you can leverage sentiment analysis, right? Where you post something and you're trying to find out, are people responding negatively to this or is it positive or something like that? So for you to do that, if you're working with text, you've got to do this. In fact, for you to do that, if you're working with, well, audio in some instances, you'd have to do this, right? Because you convert your audio into text, for instance, and then you do some smart thing here. I'm glad you're asking this question. I guess sometimes people will just be, I saw it there, say this is the code that does this, and people are just copy pasting, right? And I guess that's how we learn most of the time. I know that's how I learned Java myself. You know, it was hard to understand at first, but now I understand. Is this fine? But I hope this is fine. Are we all on the same page? I guess it helps sometimes if you understand why we are doing this, right? Anyways, you can't. See, the next step when we do this, for you to learn a model, right? Or to build something that classifies whether an act is to do with cybersecurity or ICTs or not, you're going to have to use an estimator, like an algorithm, something that is inbuilt, right? Naive Bayes, for instance, stochastic gradient descent, right? You understand? Those things are already inbuilt, but those things are designed in such a way that they will not work if you tell them, build a classifier, here's my corpus, this is the input. They will not work. They work in such a, they're designed in such a way that they're expecting you to give them numbers. And so what we understand in terms of text here is how do we convert this into numbers? We know how to convert categories. If you have text that has gender, male, female, you can't get that and give it to naive Bayes, for instance, or support vector classifier, right? You've got to convert it into numbers. Same for images, you convert into numbers. Same for text, you convert into numbers. So the question is, how do we convert text into numbers? And I know what you're thinking, you guys. Well, but Lighton, they taught us in computer systems and architecture that text, we can use ASCII encoding, right? You can do that, but people have tried those naive methods, by the way. You understand what I mean? It's like they've told you this can be represented using 8 bits, right? A sequence of ones and zeros. If you just use your ASCII table as a lookup, you say if you see S, just replace it with these numbers, these numbers, these numbers. And then you can use that as input. But it turns out this is more optimal, right? These techniques that we're looking at. And there are a number of such techniques, right? Where you are converting text into numbers. So 4-step process, collect your corpus, apply all preprocessing operations, create your vocabulary, your unique words in your vocabulary. At your own time, look up. And this will make you maybe understand why we're doing this, right? At your own time, just say what is the approximate number of words in the English vocabulary or something. To give you an idea, an appreciation of some of the things we're going to be talking about here. The dictionaries. okay, let's just say this, what they're saying, Oxford English Dictionary, about 171,000 words. So what you'd be doing when you're working with, like if you're looking at things from Parliament, you're going to be working with roughly this sort of vocabulary. And so what you're doing is, in your for loop, for each document, for each of these 171,000 words, one by one, right? You go to the document. For each document, so what you'll be doing actually, and I'm glad I did this, you would have 171 of those unique words in the English dictionary. 171. I is one of them, certainly Chela is not in the Oxford Dictionary, right? Alive is not there, but I'm just giving you an idea. You string them together and then you're going to be checking. For each of these, I'll start with I, right? How many times does I occur in this document? And so you begin to notice that you're going to have to loop through each of the words in your document. So for word in this document, right? If this word is equal to this plus 1, go to the next. If M is equal to I, which is not, plus 1. If not, it's plus 0 something. Or you just skip. And then ultimately you're going to have like a frequency. It's a simple heuristic that I thought maybe it will make a lot of sense if you do this. And really, this is the reason why I was saying that it becomes important for us to ensure that this vector we're working with is as small as possible. Because 171,000 is a lot, right? And guess what? I've told you this. If I haven't, I'm telling you right now, right? You don't work with text like that. Because we know that a certain combination of text only, some phrases only make sense if they comprise of a certain combination of words. If I say in your introduction include which university you are at, you're going to say, I am at the University of Zambia. Now, for University of Zambia to make sense, right, you need to combine 3 words, is it? University of and Zambia. Right? So you're using like what are called trigrams or something like that. Now, if you're using trigrams, it's like out of the 171,000 words, in addition to that, you're going to be looking at, because you're working with trigrams, it's a combination of 2 words. So you're going to have, one of the vectors is going to be University of, one of them is going to be of Zambia, and then you're going to use trigrams as well. One of them is going to be University of Zambia, right? And if you have something like I am at the University of Zambia, one of them is going to be at the, or something like that. And so what I'm trying to say is that it's not really, this vector that you're creating is actually not going to be 171,000 columns, right? Because these are columns that you're working with. But it's going to be a lot more. And it's a reason why we have got to remove stop words. It's a reason why we've got to stem, so that we are reducing, that thing is going to be as small as possible. Why? It's all about compute resources, right? You understand this? Anyways, so this is a heuristic, very simple really. So you create a document of vectors, and so for each document you create a vector of zeros. And by the way, what you will notice is what I introduced you to, and this was the reason why. When you use count vectorizer, what you end up with, when you do count vectorizer, you end up with a sparse matrix, right? Because, why is it important that it's a sparse matrix? You have, let's use 171,000. If I get that 171,000, if this was my corpus, you'll notice that most of the entries are going to be zeros. They'll have a frequency of 0. You understand this? Like the word unnecessary is going to be, I don't know how I feel. The word unnecessary is going to be in your vocabulary, but it will be 0 for all of us. And you have a lot of such words that will have a 0. Now, if you have a 0, the argument is that it's more optimal for you not to store all of this, but rather you just keep track of where these numbers are, right? Where these frequencies are. They taught you about algorithms and data structures. I know this, so don't act like you don't understand what's happening here. Okay, so here's a simple example here, right? Hope this will make sense. I guess I went out of my way. Let's say we have a simple corpus. Our corpus comprises of 2 documents, right? 2 documents in our corpus, right? Our vocabulary comprises of 1, 2, 3, 4 words, right? Because we are tokenizing using words, right? 4 words. And so our bag of words, the vector that we end up with, is going to be as follows, right? For the first document, all we are doing is we are checking, does I appear in here? Yes. How many times? 1 time. Does love appear? Does love appear in here? Yes. How many times? 1 time. Does the word programming appear? Does the word programming appear in here? Yes. How many times? 1 time. Does the word Python appear in here? No. So it's 0. I am doing this again for document number 2. Because this is my vocabulary, does the word I appear in this document? Yes. How many times? 1 time. I do apologize, it's a horrible example because the frequency is 1, but in some instances the frequency will be more than 1. In fact, the acts of parliament that you are working on, you'll notice that words like act will probably have like a very high frequency, right? You know why? Because in your header, depending on how you're doing the conversion, if it's a naive way of doing this conversion, the header has the word act. So you're going to have a lot of these things. Do you understand this? It's like, look at this. It's a bad example. I don't have a header here, but, right? The word act. It's horrible here, so I do apologize, but you can see certain words. The word act. So in this particular case, the word act is probably going to have a very high frequency. Yes?
So, if we're using the convert as a means of checking the frequency, then what is the purpose of the TF-IDF vectorization?
Oh yeah, so we're going to come back to this, right? What you notice with count vectorizer is very basic, right? I'll use an example of words that occur often. With words that occur often, right, you will have this illusion. Here's the thing. If I give you this, and we'll discuss TF-IDF, by the way, time frequency in this document frequency. If we use count vectorizer, if you're using a bag of words model, it's like you're telling this, whatever estimator you're going to use to say, the word I is more important than the word chela, ultimately, in this document. And in fact, relative to the entire corpus, you're telling the algorithm to say, if you see the word I, it's more important than the word chela, for instance, because chela has a frequency of 1, but I has a frequency of 2. But this is not true, right? This is not true because the word I appears in almost all the document. And if it appears in almost all the document, it's not important. If you were to apply TF-IDF, you notice that the TF-IDF value of the word chela in this document is going to be much, much higher than the word I in this document.
So it's based on the scarcity of the word?
Sorry?
It's based on the
It's based on the?
scarcity of the word.
Well, so you're looking at importance really is you're taking into account what? Importance typically is your scarcity of words, but also to a certain extent, in some instances, you'd want to say, I don't want these scarce words, right? The things that are so esoteric. Like here's the thing. If you are using this as your corpus, is the word chela important? It's scarce, but is it important? No, because it only appears, unless there's another chela here, it only appears in one document. So in fact, the way count vectorizer works is one of the parameters is such that you are indicating, you are telling it to say, if you have words that appear in less than 10% of the documents, drop them. If you have words that appear in more than 80% of the documents, drop them. The goal is always to make sure that the resulting vector that you're working with is as small as possible. But also, it turns out that these are the hyperparameters that you do this as part of hyperparameter tuning. So, and I think we'll talk about this here. Typically, the standard way is you're splitting into test and training, but it's always advisable to also have a validation data set, right? So as part of your validation, you're tuning these parameters, you're checking, if I drop words that appear in 10% of the documents, do I end up with a model that is more effective than if I keep them? Or than if I just drop 5%? Right, so it becomes a factor. In other words, those hyperparameters become factors. But anyways, that's I hope this is making sense here. And so the vector represents really the presence or absence and frequencies of words. You're building a vector that has frequencies of words, right? You're just counting. It's simple, you know. Very simple actually, if you ask me. Now, I guess it becomes important here to say, but what are the advantages here? Very basic to implement. You can actually implement it yourself, right? I've just given you the heuristic. If I say go and write a program that does that, which I've done in the notebook, by the way, you can do this. You're just looping and counting, that's it, right? It actually turns out that it works surprisingly well here, right? For small to medium size datasets. In fact, we've worked on problems where the models that we've implemented, these document classifiers, I worked with Robert and we did a whole range of things here. We're working with titles and abstracts of text. Believe it or not, in some instances, our models, our classifiers, had a better accuracy in instances where we were using count vectorize and not TF-IDF. So we had that as a factor to say, we're going to look at the effectiveness of the model if we transform the data using count vectorize and compare it when we transform the data using TF-IDF, right? So it works quite well for small to medium sized data sets. My advice to you, and we'll discuss this as part of evaluation, is don't assume just because all the examples you come across use TF-IDF, then we are going to implement our model by transforming the data using TF-IDF. No, you must experimentally determine this, right? In fact, there are a number of other techniques, right? It's not just count vectorize and TF-IDF. Continuous bag of words model, BERT, and all those things. But anyway, so the disadvantage we see here is you ignore the word order, obviously, right? And then the meaning as well, right? Because you're just looking at individual words or combination of words. If you know what I mean, right? If you're just looking at one of the words is chela, what is that, right? One of the words is light, what is that, right? Doesn't have any meaning, there's no meaning there. But also, this is an important one, it can lead to high dimensional and space vectors. And as a result, you end up with a situation where this offline model that you're creating takes a long time, right? To learn or something like that. Especially in instances where, here's the thing. If you were to say, you're going to be working on a solution looking at what is discussed in Parliament. We know that some parliamentarians, some members of Parliament will use Bemba, right? They'll use Nyanja, I don't know if you use Tonga or something, or Silozi. It's like your vocabulary is going to be so large, right? And if it's so large, it's going to be a high dimensional space vector. You know, so it becomes tricky to work with something like that here. Now, just put it out there. I have another example from our corpus, the student at risk of failing corpus. Step 1, I have these two documents. I'm going to create a vocabulary, right? Step 1. Step 2, for each one of these documents, I'm just keeping track of the counts, right? I'm counting how many times is I want to learn and stuff, right? I'm going to leave you with this, right? I'm going to say the notebook has, in the section, it has a step-by-step outline of how you can implement this. But at your own time, why not try and implement this, right? You can. You're just looping. Why don't you loop and see if you can implement count vectorize or the bag of words model? You understand this? When we meet tomorrow at 18 hours, I think, it's 17 hours. Sorry, we're supposed to meet at 12 though. I don't know if I'll try and see if I can come again. I hope I won't be facilitating a session, but when we meet virtually, I guess, I want to walk us through TF-IDF. By the way, you can still go and look at it. It's like you are augmenting to the things that we've looked at as part of our discussion of the bag of words model, but you're including the inverse document frequency part here. So if you look at the overall formula here, you notice that we are getting the log of stuff and all that, right? So we discuss this, and then the moment we're done with this, we shall transition to model implementation on Saturday, right, at 18 hours. So tomorrow we have class at 12. And then today at 18 hours we have lab number 3, right? And yes, we've taken into account, where's Dennis? We've taken into, we've taken into account time here. We'll give you a lot of time. It's an experiment today, we'll see. Yes? Yep.
What would be in the lab today?
Excuse me, there's a question, what would be in the lab? Oh, come on, man. What would be on the lab is, Sam. What would be in the lab is everything we covered before now.
Oh, before now?
Yeah, we're not including.
Lecture series 4.
Yeah. Please, my register. Thank you. But what? Wow. Where are we rushing? Yes.
So we have to use in the lab.
No, the quiz is the lab.
Oh,
Yeah.
okay.
Thank you very much.
I have a question.
Yes, yes,
The code snippets,
yes.
that is in red.
Sorry?
They're in red.
Yeah, they're in red because I wanted to make a distinction between
No, like it's difficult, sir.
or to read.
Yeah, like to read the code snippets, all they're in red. Like,
Okay. I'll change the font.
Yeah.
Yeah, thank
Or
you.
maybe a bit of.
Not a problem.
Even better, just take like your VS code, right?
Yes, I have
Yeah,
that.
just do it.
Well,
Then
the problem
take
is,
a
yeah, so the problem with that is zooming in and zooming out if I do that. But I'll change the color, that's not a problem. Yeah, right. It's bad? Yeah, that's fine. Right. Excuse me, Miss Madam. Miss Madam? Hi. Can you unplug for me, please? Thank you. Yes, yes.
You said the quiz will comprise of everything we've done before now.
Before now, yeah.
So the deep understanding part, everything.
Well, I mean, so what we've done is quiz is based on 4, on lecture series 4. Yeah. That stuff. Oh yeah. So it's data understanding type. No, data preparation.
Data preparation.
Was it data preparation last week?
No, we're still doing data preparation.
Preparation.
Yeah, this is preparation. Hey, hi. So, sorry, your name?
Dave.
Oh, Dave. Yeah. Is it Lee Dave?
No, Dave.
Just Dave.
Dave
Okay.
with the Y.
Oh yeah. Yes, yes, yes.
Yeah, I've got a question.
Please.
How does it work?
Yeah, of course.
Okay, so it's just lecture series 4, but data preparation.
No, what we've covered, I don't know what we've covered in lecture series number 4, excluding this stuff.
Okay.
Yeah.
So excluding this stuff.
Yeah,
that-
so we
no
went-
natural language processing.
No, but we did that. What are you talking about?
What that means natural language processing?
The NLP was part of the pipeline.
And also, sir, you talked about
Yeah.
data scaling.
Yes. Yes, let's go. We ask about scaling.